Okay, so now let us discuss about the integral. So recall that we discussed about the Riemann sum. And the characteristic of a Riemann sum is we have a variable height given by f of x, but a fixed width, delta x, which is given by b minus a divided by n. Recall the curve. What we are being asked to find is the area in between the curve from a to b, a and b. And with Riemann sums, we take little rectangle slices with a fixed width but variable height. And in this case, this is roughly a flat top, so it's okay to approximate as a rectangle. But in situations where we have slopes like this, we need different variable height. Here, what we want to introduce is the notion of the integral. So here, Riemann sums only give us an approximate area given by n, the sum from k equals 1, f of xk, delta x. What this is essentially saying is take a bunch of rectangular sections of the curve and add up the area and add up to get the approximate area. Now, notice that the more rectangles we add, the better. And more rectangles are squeezed in using very, very tiny width. So if we have an infinite number of partitions or cuts, we are pretty much approximating the area underneath this curve. So to put this into equation, when the area, we can get the exact amount of area by taking the limit as n goes to infinity of the Riemann summation. Essentially, this states that we have an infinite number of very, very tiny rectangles, because recall that the formula for this is b minus a over n. So we have something that approaches infinity in this direction, means we have really small rectangles. And the more rectangles we have, the more exact our area is going to be. This notation we replace by a different symbol. So the limit as n goes to infinity of n with the summation starting at k equals 1 to n of f of x, k, delta x, is given by this symbol. This symbol is called the integral. And in this case, we have what's called a definite integral, which is going to be discussed in the next section. The integral from a to b of f of x dx. Notice that we didn't change too much on our notation. Our variable height is still present, but our width is what's called infinitesimally small. Infinitesimally small. So we could have the curve between a and b in reference to this to occupy the entire area underneath the curve. In the next section, we're going to differentiate between the definite integral and the indefinite integral, and we will also explore some main rules for doing integration. All right, thank you.